Welcome back to my YouTube channel. So in last video we have seen the unit load method for the pin jointed frames. So now we will see the working concept of working rules of unit load method for the pin jointed frames. It is nothing but trusses. Now we will see what is the procedure for solving the trusses by using the unit load method. So working rule of unit load method for finding the deflection in trusses. It is also called as pin jointed frames. So first we will see what is mean by truss. A truss is made of straight members connected by pin joints. Here it is the member should be straight and it is connected, one member to another member is connected by the pin jointed. See here, these are the pin joints. One member to another member connected by the pin joints, and load act only at the joints. Always in truss, load act only at the joints, not on the member. It acts only joints, here, only at the joints. This is the definition of the truss, and the steps involved in this is, first step is, step 1 is find out the support reaction. So here our in support is there. For in support is how many reaction will take place? One is vertical and another is horizontal, and at roller only one vertical reaction takes place. We need to find the support reaction. This is our first step, to find out the support reaction of the given truss. Our second step is to find out the P analysis. P analysis means we need to find after find outing the support reaction, we need to find the forces in each member by taking the separate joints and applying the equilibrium equations of summation of Fx and summation of Fy. By taking the equilibrium equation, with the help of that we need to find the forces in each member by taking the separate joints. This is called as P analysis. And our third step is to find out the K analysis. So K analysis means here we need to apply the unit load of 1 kN at the point where they ask to find the deflection. Here we need to remove all the actual loads, whatever they have given in problem. We need to remove all the external loads, and we only need to apply here unit load of 1 kN at the point at the joint where they ask to find the deflection. And here also we need to find the support reaction. This is our third step. And our fourth step will be, there will be one table come, and K analysis. Our fourth step is, there will be one table comes. I will show you while analyzing. So this is our 4 steps we need to remember while find outing the trusses by using the unit load method. And one more important thing is, see here I will tell you how to find. If you take this joint, the forces is, here on force is acting in this direction, here on force is acting in this direction. So opposite to this there is no load, no. So the force becomes 0. Here also force becomes 0. If you apply the equilibrium equation, summation of Fx and summation of Fx and summation of Fy, the force, the value, the force becomes 0, because there is no any load opposite to this, and here also there is no load opposite to this. For that the value becomes 0. So it is called as the zero force member. It is called as the zero force member. Zero force member is nothing but a member that carries the zero force under a particular loading condition. It helps maintain the shape of the truss, but it does not carry any load. So for example, see here on force is there, here on force is there. So opposite of this is force is there, opposite of this the load is there, there will be some value. So opposite of this force there is no load, no, the value becomes 0 for this. And similarly, for if we take like this is the joint, the force is coming like this, here also the value becomes 0, here also the force becomes 0, because opposite in this direction there is no load, in this direction also there is no load, no, the value becomes 0. And similarly, for if we take the force is acting in this direction, here the force becomes 0 because opposite to this there is no load. Here opposite to this the force load is acting, no, here there will be some value. If you apply the equilibrium equation, that is summation of fx and summation of fi, there will be some value. So by find outing the each joint, to find the force in each joint, we need to apply the equilibrium condition, that is summation of fx is equal to 0, summation of fi is equal to 0. We need to apply this formula. The forces in each member, we need to apply these two conditions, and by using these two equilibrium equation, we need to find the forces in each member. The possible forces will be to one is tension or either compression or tension. Now we will see the sign convention for that. So if the forces is moving towards each other, when the forces are moving towards each other, then it is called the member is in tension. Tension means it is positive. So if the forces are moving away from each other, means it is in compression, so it is negative. So in tension the forces moves towards each other, and in compression the forces moves away from the each other. Away from each other means away from the joint. Here in tension forces moves away from this joint, and in compression the forces moves towards the joints, and the forces moves towards each other. So this is the sign convention of trusses. It is very important while analyzing. It is important to remember. So when it comes to the beam, so it is a beam. Here what happens in tension, forces will move away from each other, so it is positive. And in beam, if the forces is move towards each other means it is in compression, it means negative. So the sign convention will be different for when it comes to the beam and truss. So in truss what happens, here the forces is moving towards each other, then it is called the force is called the tension. But when it comes to beam, the forces is moving away from each other, then the force is called it is in tension. So when it comes to compression, the forces is moving away from each other means in trusses it is called the compression. And in beam, when the forces are moving towards each other, then it means the force is in compression. So both are different, don't get confused here about the sign convention. And these are the steps, these are the 4 steps we need to remember while analyzing the trusses. So I'll solving the problem, I will tell you. So in next video I will solve a problem on this truss, where you will get to know each and every step clearly. If you like the video, like it, share it and subscribe for the more videos. Thank you for watching.